So I want to talk about section 7.1. And here we're talking about measurement. Now, one of the things we're going to probably do is take a look at how there's a whole bunch of different measurements in here. And we're not going to really ask you to memorize these, but we want to have you take these different sort of relationships between measurements. This is going to be like 12 inches equals 1 foot, and use those relationships to help make conversions. Why are we converting measurements? Well, when we measure something, say, in long distances, say the distance from Roswell to Vaughan, we don't measure that in inches. We measure it in miles. It might be kind of hard to conceptualize the inches. And miles is just smaller numbers, they're easier to work with. If we're going to do this in inches, you're going to be dealing with enormous amounts of inches. You have to be very proficient at multiplying, dividing, adding, and subtracting these large numbers of inches. But if we do this in miles, then the number of miles isn't quite as big. So it's roughly 90 or 100, for example, from Roswell to Vaughan. We'll figure out what that is in inches later. And well, those numbers are easier to multiply, divide, add, and subtract. For various historical reasons, different societies use different types of measurements to measure distance or weight, things like that. For example, in the United States, we use sort of what we call the US system, but it used to be called the British imperial system. And the idea is that we would measure distances, say, in miles, while in mainland Europe, they use it for various historical reasons. They use kilometers to measure distances. And so there's those kinds of things that we want to be able to translate from one measurement system to the other. And this is going to just not be limited to measurements that we make using the sort of the official systems. There could be sort of quantities that people come up with on their own, and we need to convert those to more familiar quantities for ourselves, and vice versa. So this is a technique that can be very useful pretty much in all sorts of ways. Well, let's take a look. Let's go back to inches and feet. So we know there's a relationship between inches and feet. And it's 12 inches is the same as 1 foot. Now, what we're going to do is something that might seem kind of strange. Let's divide both sides by 12 inches. If we do that, well, something divided by itself is 1. So we get 1 foot over 12 inches. So what this says is this. A foot is the same distance as 12 inches. So if you take this distance divided by itself, just expressed differently, but these are the same quantities, well, we should get 1. Now let's say we did something different. Let's divide each side by 1 foot. So we get the same kind of result, except this time the inches are on top and the feet are on the bottom. But again, the ratio, because these represent the same distance, we're dividing something really by itself, it's equal to 1. And I would have put on the other side here the result that we got when we divided by 12 inches on both sides. That was 1 foot over 12 inches. So the point is, whether it's 12 inches over a foot or a foot over 12 inches, same lengths, and a ratio of the same things is going to give you 1. This is going to help us do our conversions, because multiplication by 1, we're going to use multiplication by 1. It doesn't change anything. So let's take a look. First, we need to talk about this thing called dimensional analysis. For us, what this is going to mean is that units will cancel each other. You can multiply and divide units. So units, what are units in this case? Well, we can talk about units as like ones, but we're going to talk about like a unit, another unit, a distance of 1. We're not talking about that necessarily. We're talking something more specific, like 1 inch, another inch, or a mile, another mile, and so on. So when we talk about units, we're really talking about like miles, inches, pounds, kilometers, these kinds of things. Well, you can multiply just the units together. For example, an inch times an inch, we'll call this inch squared. Just like 3 times 3 is 3 squared. We could also take, let's say, a pound times a pound divided by a pound. Cancel a couple of those, and we'll get pounds. So we can multiply and divide these units like they're numbers. And we do this separately from numbers. So we'll multiply and divide numbers off to the side. We'll multiply and divide units off to the side. So one of the key things, and we're going to see this, we have, say, hours times kilometers over, let's say, pounds. And if we multiply by something like this, let's say, think of a time, unit here, ounces, not ounces, because that would do something else. Pardon me, it's morning, I'm trying to think, I guess the brain's still warming up. So let's say we're going to multiply by, okay, we'll go with ounces. And then we have kilometers times gallons. So just a bunch of units. Well, you might remember from multiplying fractions that when you have something repeated in the top and the bottom, you can cancel those. So we can cancel kilometers. And when we cancel kilometers, we get hours over pounds times ounces over gallons. And then we multiply across like we usually multiply fractions. But this is the key thing. When you see this repeated top and bottom, that means we cancel. This is going to be key for our dimensional analysis. It's going to be key for our conversions. So this is how it works with conversions. Let's convert 6 feet to inches. So what we're going to do is this. We're going to recall that 12 inches equals 1 foot. And that gives us 2 conversion ratios. 12 inches over 1 foot, or 1 foot over 12 inches. And remember, these are just equal to 1. They're all just equal to 1. 12 inches is the same distance as 1 foot. 1 foot is the same distance as 12 inches. So this is just 1. So what we can do, let's take our 6 feet. We'll multiply by 1. So here's the key thing with conversions. We're not changing the quantity. We're just changing how it looks. Instead of looking at this distance as feet, we want to look at this distance, same distance, but divided into inches. So same distance, just divided up differently. So multiplying by 1, this isn't going to change anything. But then what we can do, we can choose one where it could be 12 feet over a foot or a foot over 12 inches. Now what we want to do, we want to choose the correct conversion ratio. What I mean by correct is we want one that causes feet to cancel and inches to remain. So if we choose this one, 12 inches over 1 foot, we have feet in the top, feet in the bottom. Now keep in mind there's a invisible 1 underneath. Every number has an invisible 1 as a denominator. And again, anything divided by 1 doesn't change it. So here we have feet in the top and feet in the bottom, just like we had kilometers in the top and kilometers in the bottom. So that means feet will cancel. So what we're left with, 6 over 1 times 12 inches over 1. And with multiplying fractions, we multiply across, directly across. So we'll get 72 inches over 1, 72 inches. Now, I've thrown in a lot of extra steps that you don't need. Like you can just tell yourself that this is always going to have a 1 in the denominator. And you can maybe skip this step because you got 1 times 1. And so you can just get to the 72 inches. You don't have to write this step if you want. But I'm putting in all the steps just to show you what's going on. So when we do some shortcuts, well, there's still some stuff going on in the background. There's shortcuts. They're not automatic. So hopefully that's not going to make things confusing. All right, so let's do another one. So let's say we're going to go kilometers to miles. So let's say we're going to do this. Convert 55 miles per hour to kph, which is kilometers per hour. So we want to do some rewriting with this one first. 55 miles per hour. This is 55 miles per 1 hour. So we want to convert this to kilometers per hour. So we're going to convert miles. We want miles to become kilometers. So we need a relationship between miles and kilometers. Now, taking a look in the text, I'm looking on page 360. They do give an approximation. 1 mile is approximately 1.61 kilometers. So let's take our 55 miles per hour. Now, what conversion ratio should we use? We're going to get choice of 2, either a mile on top of 1.61 kilometers or 1.61 kilometers on top of a mile. Well, it depends what we want to do. We want miles to become kilometers. So that means we want miles to cancel and kilometers to remain. Now, the only way for kilometers to remain, or I'm sorry, let's take a step back. The only way for miles to cancel, because miles is in top it'll only cancel if miles are in the bottom. So that forces us to say miles has to go here. And that means the kilometers, that's the only place the kilometers could go. And then take a look. The miles will cancel, which is what we want. And the kilometers remain, which is what we want. So we're done. We did it. We put in 1 here for 1 hour. So this gives us 55 over 1 hour times 1.61 kilometers over 1. And then we just multiply across. 1 times 1 is 1. And then hours, well, it's just going to be hours. Then 55 times 1.61. It's 88.55 kilometers. Or we can, since this is 88.55 kilometers per 1 hour, can we write this as 88.55 kilometers per hour, kph. Now notice in this problem, hours just kind of went along for the ride. We weren't going to do anything with hours, and we didn't do anything with hours. That's perfectly fine. All right. So let's do another one. Now, let's say we're going to convert 60 miles per hour to miles per minute. Well, first off, let's rewrite 60 mph. That's 60 miles per 1 hour. So we want to go miles per 1 hour to miles per minute. Well, in this case, the miles we're not going to convert. We're going to convert the hours to minutes. And we have a relationship between hours and minutes. One hour is 60 minutes. So we'll start out with our 60 miles per hour. And we want to convert the hours. We want the hours to disappear, and we want minutes to replace it. Now, in this case, the hours is in the bottom. So this will only disappear if hours is in the top over here. So that means when we do our conversion ratio, again, we have 2 to choose from. We can do hours, 1 hour over 60 minutes, or 60 minutes over an hour. But since hours is in the bottom here, we need hours in the top. It's the only way for hours to cancel. So we'll put 1 hour up here, and that means the 60 minutes has to go in the bottom. And sure enough, the hours are canceling. This leaves us with 60 miles. We multiply across times 1 times 60 minutes, or 60 miles over 60 minutes. And you can just divide the 60s maybe a more specific way. It's typical to want to have a 1 when you're dealing with like miles per hour or inches per second, something like that. Let's divide top and bottom by 60. 60 divided by 60 is 1. And 60 divided by 60 is 1. So what we find out, 60 miles per hour is the same as 1 mile per 1 minute. And there we go. Let's do another one. I mentioned the relationship between miles and inches. So the distance to Bonn from Roswell is roughly 100 miles. So let's convert 100 miles to inches. Now let's take a look. If we look in the book, we're not going to find a relationship between miles and inches. There is one between miles and feet. And there is one between feet and inches. But there's nothing directly between miles and inches. So what we're going to do is this. We'll first convert our miles to feet, and then convert our feet to inches. So let's start with our 100 miles. And remember, there's an invisible 1 under here. So that means the miles is on top, and it's on top of that invisible 1. So the invisible 1 is on the bottom. Now we want to go miles to feet. That means we need miles to cancel. So since the miles is on top, again on top of that invisible 1, we need miles on the bottom. So that means for this part, we have a mile over 5,280 feet, or 5,280 feet over 1 mile. Well, we're going to need the 5,280 feet on top of the mile because we need the mile on the bottom. And so far, so good. Miles are canceling, and feet are remaining. So that means we've converted from miles to feet. Next, we need to convert from feet to inches. Here to here. So for this one, 12 feet equals, 1 foot equals 12 inches, or 12 inches equals 1 foot. Now, in this case, we got feet on top, so that means feet have to be on the bottom to make feet disappear so we can have inches. So to make feet disappear, 1 foot on the bottom. And that means 12 inches has to go on top. And just to be thorough, there's that invisible 1. It'll help us do multiplication. So now we just multiply across, multiply everything on the top together, multiply everything on the bottom together. And sure enough, just to double check, feet, they're canceled. They cancel when there's a top, it shows up in the top and bottom. So doing that multiplication, we'll get 100 times 5,280 times 12 inches. We have 1 times 1. Now on the bottom, 1 times 1 times 1 is that's 1. And then up here, let's do that calculation. 100 times 5,280 times 12. And so what we get is 6,336,000 inches. And again, anytime you divide something by 1, that doesn't change anything. Just write that. Now, the issue here is when we're doing arithmetic, especially if we're doing it in our head, it's going to be harder to deal with bigger numbers than, say, 100 miles. 100 is probably easier to handle than numbers in the millions. So this is why one reason why we might look at larger distances in terms of miles, divide them up into miles instead of dividing them up into inches. All right. So I think that's going to be it for section. That's basically what they do in section 7.1. There's one more type of problem I do want to go over, and this one's a tricky one. How do you do this problem? There's a couple ways of going about it. What these are, these teras and these yotas, they've got gigas. In fact, tera has 1 R instead of 2. Let me see, let me double check yota there. Yota does have 2 T's. These are kind of abstract quantities. So they're not necessarily talking about pounds or inches when they're doing this. This is something you can say, have you ever heard of a terabyte? A byte is a unit of information. Now a bit is 1 or a 0 that's stored on a computer. 8 bits, or 8 zeros and ones, is a byte. And then we have kilobytes, which is 1,000 bytes. We have megabytes. We have gigabytes. This is just greater numbers of bytes. And then we have terabytes, yottabytes, that are even bigger numbers of bytes. So when we talk about a lot of something, we'll talk about tera. So it's a certain number of bytes, big number of bytes. And here we're not attaching bytes or inches or miles, which can seem kind of abstract. So I'm going to approach this 2 different ways. And I'm going to do it the abstract way and then a more specific way. So tera, which is represented by a capital T, is 10 to the 12 of something. It could be 10 to the 12 inches, it could be 10 to the 12 gallons, but it's 10 to the 12 of something. Now, yota represented by capital Y is 10 to the 24 of something. Now, if you're wondering, it's been a while, what do these actually mean? Well, 10 to the 12 means you have 12 tens multiplied together. And when you do that, that gives you a 1. 12 zeros. So if you take 12 tens and multiply them together, you're going to get a number like this. It's kind of like with 3 squared. It's 3 times 3. 10 to the 12 is 10 times 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 10. So 10 to the 12 is 12 tens multiplied together. 3 to the 2 is 2 threes multiplied together. And 10 to the 24, that's 24 tens multiplied together. Now, sort of a shortcut you can do with this, and this works with tens. You can come up with the answer really quickly. If you have a 10 and a positive exponent, just write a 1 with a bunch of zeros. And how many zeros do you write? The number of zeros here equals the exponent. So this is just a shortcut. So 10 to the 12, just write a 1, 12 zeros. 10 to the 24, you write a 1, and then 24 zeros. Anyway, So how do we do this? Well, we're just going to do generic units. So instead of choosing bytes or pounds or something like that, let's just do units. So we have this relationship. 1 T unit is equals 10 to the 12 regular units, whatever those might be. 1 tera-inch would be 10 to the 12 inches. 1 terabyte, 10 to the 12 bytes. And then we have 1 iota. That's 10 to the 24 units. So a iota unit is 10 to the 24 regular units. So we want to convert 4.3 tera units to iota units. So we start out with our 4.3. We want tera units to cancel. Now, here's a trick I'm going to recommend. Let's convert T units to regular units, and then convert regular units to iota units. So let's do this conversion first. So we want tera units to cancel, we want units to remain. So we have a relationship between tera units and regular units. We want the tera unit to cancel. So we have 1 tera unit. And again, using this relationship, that's the same as 10 to the 12 regular units. So sure enough, our tera units are canceling, and don't forget there's that invisible 1 there. And so we've done it. We've gone tera units to regular units. But now we want to go regular units to iota units. So now we want the regular units to cancel, iota units to remain. So we got to look at the relationship between iota units and regular units. Well, we want regular units to cancel. So regular units are on top. We need the regular units on the bottom. So that means this, 10 to the 24, goes on the bottom. And the iota unit, because we're converting from units to iota units, that means we're working only with this relationship now. The iota unit has to go on top. There's no other place for it to go. So sure enough, our units are canceling. And now we multiply across. So we get 4.3 times 10 to the 12 times 1 per unit. And then on the bottom, we have 1 times 1 times 10 to the 24. So times 1 doesn't do anything. And we leave this in what's called scientific notation. So we can say this is 4.3. And we actually use the time symbol instead of the dot. But you can put a dot there, but I think they use the time symbol in your homework. On the bottom, 1 times 1 doesn't do anything. We'll just get 10 to the 24. Now, what we do here is we can either divide the 10 to the 24 into the 4.3 or divide it into the 10 to the 12. And we want to divide it into the 10 to the 12. And for our final answer, we're going to use a trick that has to do with exponents when we divide them. There's a rule that goes like this. So an exponent has a base and an exponent. So an exponential expression, I should say. There's a base and an exponent. And when the bases match, like they do here, we always subtract the bottom exponent from the top. So what we'll get is 4.3 times 10 to the 12 minus 24 iota units. And even though this is a smaller number than this one, you always subtract the bottom from the top. So we're going to subtract the 24 from the 12. And what we'll get is 4.3 times 10 to the negative 12 iota units. And finally, we just drop this unit here. 4.3 times 10 to negative 12 iota. So that's an abstract way of thinking of this problem. Now, in your homework, they'll have two blanks. They'll have a blank for this number and then a blank for your exponent. And to get the question correct, you want to enter this number correct and enter the exponent correct. That's usually how they do that. Now, there's another approach to this, which is a little less abstract. So let's say we're going 4.3 tera to iota. Well, let's give these an identity. Let's say instead of tera and iota, let's say tera inches to iota inches, or tera pounds to iota pounds, or terabytes to iota bytes. So we'll just call it this, terabytes to iota bytes. Make it more concrete. And then we need our relationships. 1 terabyte is 10 to the 12 regular bytes. And 1 yottabyte is 10 to the 24 regular bytes. So what we're going to do, we'll go terabytes to bytes to yottabytes. We're going to do the exact same procedure as we did with the generic units. But sometimes when it's more concrete, it's just easier to think about. So especially if it's something familiar. So if you're more familiar with inches than bytes, go with tera inches to iota inches. That would work too. So again, we take our 4.3 terabytes. And don't forget your invisible one. And that means terabytes is on top. We want to convert it to regular bytes. First things, that means the relationship terabytes, regular bytes is right here. We want terabytes to cancel. So that means it has to go on the bottom because terabytes here is on top. Now again, if terabytes were down here, our 1 terabyte would have to go up there. But in this case, terabytes are on top. So for our conversion ratio, it's going to be terabytes on the bottom. And that's equal to 10 to the 12 bytes. Terabytes are canceling. We're on the right track. Next, we need to go bytes to yottabytes. So that means we need this relationship now. We need the bytes to cancel because we're going bytes to yottabytes. That means this has to go on the bottom. And then the 1 yottabyte, that goes on top. And to check, sure enough, bytes in the top, bytes in the bottom means bytes cancel. And if we check our work, we started with terabytes, it cancels. We went to bytes, it cancels. And we're left with yottabytes, which is what we wanted in the end. So we multiply across. times 1 doesn't do anything. And times n by 1 doesn't do anything, so we just get 10 to the 24. And again, they use the time symbol as an X here, that little tiny X. And again, we want to divide the tens. So 4.3 times 10 to the 12 minus 24 Yotta bytes. Or 4.3 times 10 to the negative 12 Yotta bytes. And then finally, we just drop the bytes. 4.3 times 10 to the negative 12 Yotta. And that's it. So if you have any questions about this, let me know, and well, have a good day.